Another application of differentials is error propagation. This is identifying the error of approximating a certain entity. Welcome to differential calculus. As defined, the differential is a small discrepancy which arises due to approximating a certain entity. Discrepancy can also be tagged as error, and there are two types which are tackled here. The first is relative error. This is the basic discrepancy of the value due to the approximation. Relative error is computed as the discrepancy over the entity. RE is equal to dy over y. The second error is percentage error, which is basically the relative error in percentage form. The first problem involves a sphere with a given radius of 10 inches. The measurement of the radius has an allowance to errors of 0.05 inch. This is plus or minus 0.05 inch, and we are to look for the relative error in the volume. Identify the given parameters. First is the radius of the sphere taken as 10 inches. This is notated as r. Then there is the plus or minus 0.05 inch error. This is an error in measuring the radius, so this is tagged as dr. We are to look for the relative error in the volume, as there is a discrepancy in measuring the radius. So this unknown can be written as dv over dr. Since volume is involved, take its equation in terms of the given parameter r. That is v as equal to 4/3 of pi r cubed. Generate the unknown dv and also the given dr from the function, and that is done by differentiating it. dv over dr is then 4/3 of pi times the derivative of r cubed, which is 3r squared. Then attach dr over dr from chain rule. dr over dr is also 1. Simplifying the function as dv over dr as equal to 4 pi r squared. Cross-multiply dr to the other side and get dv as 4 pi r squared times dr. Having this equation, we can then substitute values of r and dr. That makes dv as 4 pi times 10 squared multiplied by plus or minus 0.05. dv is then taken as plus or minus 62.83 cubic inches. Now let's take the volume by plugging in 10 inches into 4/3 pi r cubed. This gives 4,000 over 3 pi, or 4,188.79. The relative error is the ratio of dv with v. That is 62.83 over 4,188.79, where RE is 0.015.